So far, we've been talking about static electricity, which is a build-up of charges on an object. You have experienced static electricity when your socks get stuck to each other when you pull them out of the dryer, or when you shuffle your feet across the carpeting on a cold winter morning when it's really dry, and then you touch a doorknob and then you get shocked. So you're familiar with static electricity, but static electricity isn't overly useful to us. It's much more useful to us if we can get electricity in a form where it's going to flow in a current. And one way that we can utilize current electricity is by using a battery. Now, a battery actually stores two types of materials. It stores one type that wants to gain an electron, and it stores other types that want to lose electrons, and it stores them in opposite ends of the battery. Or in two different sections of the battery. Now, we're actually going to talk a lot in chemistry. If you take chemistry, we'll really get into the nitty-gritty of how a battery works and how all those charges are transferred. It's a little bit too much for physical science class, but we will get into it when you take chemistry. For right now, what you need to understand is that one substance wants to gain electrons and the other substance wants to lose electrons. So, if you have a battery, and I assume that you probably have enough knowledge of batteries to recognize that batteries have a positive end and a negative end. And so if you take a battery and you take a wire and you hook together the positive and the negative end, you will enable current to flow because electrons want to go from this end to the other side. That's the way a battery is designed to work. Now, we actually have a little bit better way to symbolize this when we draw it. Usually a battery is just symbolized by a long line and a short line like this. And so I would actually draw the same circuit that looks this way. A circuit is just a loop that electricity runs through. And so the longer line is the positive side, and the shorter line is the negative side. Now, you don't normally write the positive and the negative on here, so after this I won't do that, but just so for right now so that you'll remember, the long line is the positive side. I remember that because here I've got two pieces that actually have to cross each other, and here I just have a negative sign. So we already talked about the fact that electrons are going to go around this direction. Let me put that in a different color. So electrons are actually going to flow this direction. So this is the actual direction of electron flow from the negative side to the positive side. But what you will see is that if you start examining circuit diagrams and different things like that, you'll see that that's not always the way that they are labeled. And the reason for that is because Benjamin Franklin did a lot of work with batteries and electricity, among all the other things that he did too. But they didn't completely understand how electricity and batteries worked then. And what Benjamin Franklin thought at the time was that there was some sort of a particle that the positive side had extra of, and that all the extra side in the positive must be flowing to the negative side that didn't have enough of it. And so when he diagrammed the flow of electric current, he always diagrammed it going this direction, like that, which is backwards of what we now understand the electron flow to actually be. The problem was that it took quite a while for our scientific knowledge to catch up with the fact that we already knew that batteries were able to produce current and electricity. And once scientists realized, okay, this is actually electrons that are flowing and they're actually going from the negative to the positive, all the engineers were saying, we're so used to drawing it this way, we don't want to go back and go change all of our diagrams now. And so to this day, current is still diagrammed as flowing from positive to negative, even though it doesn't really do that. So this dotted line is the direction of what's called conventional current. And what that means is it's our convention, it's our tradition, that that's the way we diagram it, even though we now know that scientifically it's not actually the way that the current flows. Now, There's also a difference between DC current and AC current. DC current is what this is. This is called direct current, and it only flows in one direction, in the direction, as we said, like that. And so direct current flows in one way. And so direct current is going to happen when you have a battery hooked up to something. Your house current, however, is AC, which is alternating current. And alternating current actually flows both ways. It will flow this way, and then it will flow this way, and then it will flow this way, and then it will flow this way. And a lot of current will switch back and forth about 60 times a second. And so the current's called 120 hertz because it actually flips that many times in a second. And so this alternating current is going to be what your house current actually does, where the direction is constantly changing. But we're going to talk mostly about DC current just because that's what we're going to be hooking up with batteries, and it's a little easier to understand. But I do want you to be aware that AC is what your house is going to be wired with. Okay? So you're also going to see in your book that they talk about conductors and they talk about insulators. Conductors are just very simply things that conduct electricity well. And insulators are things that do not. So metals are going to be conductors because electricity will run well through them. Things like plastic and rubber are insulators because electricity does not run well through them. And we'll also discuss about, when we talk more about atoms, we'll talk about why some things are really classified more as conductors and some are more classified as insulators. Now you do have some that are classified as semiconductors, which have properties kind of somewhere in the middle. And so just be aware that it's not necessarily going to be one or the other. There's a whole spectrum of whether things conduct well or whether they don't conduct well. And so it's not necessarily a one or the other proposition. There's kind of a spectrum. And so there's things in between that as well. So that is electric current.